Test 6 Section 2 of the official SAT study guide. All right, here we go. There's a lot of problems, it feels like, on this section. When Mrs. Yun arrived at the grocery store, there were 5 packages of hot dog rolls left on the shelf. One package contained 12 rolls, and each of the others contained 8 rolls. If Mrs. Yun bought all 5 packages, how many hot dog rolls did she purchase at the store? Well, there's 5 left. One package had 12. 4 packages had 8, so we just multiply that all together, and we get 44. I found out something when I did this section. I didn't use my calculator at all. I just did everything by hand. Isn't that crazy? Okay, A, B, and C are points on the line in that order. So draw yourself a line if you need to. I always need to draw a picture. A, B, and C. AB is 30. So AB is 30. And BC is 20 more than AB. So don't miss that part. 20 more than AB. So if AB is 30, this is going to be 50. What does AC equal? We'll just add those all up and we're going to get 80. All right, next one. This one, A equals x plus 3 equals A. So what you can do is solve this for x. This is the longer way to do the problem, but it's the most straightforward. So it's a minus 3, and then you plug that in right there. So you get 2 times a minus 3 plus 6 equals what? So we get 2a minus 6 plus 6 equals whatever. And the negative 6 crosses out, and you get 2a. If you look at it closely, you can see if A equals this, then 2 times this is going to give you that. But that's definitely a harder way to look at it. It's faster, but you don't normally see that. All right, let's go to the next page. Okay, this one. My computer's having a little delay, so I'm going to try plugging it in, see if that helps. Okay, for which student was in charge? For which students was the change in scores from test 1 to test 2 the greatest? Well, you're just going to figure out these. Test 1 are on the bottom, test 2 is right here. So when we're looking at B right here, he got an A on, or 40 on test, we're doing B, I guess. He got a 40 on the first test, a 60 on the second test, so the change was 20. Let's go to guy A. Got a 40 on the first test. He got a 70 on the next test, so the change is 30. So we're just going to go through all of these real fast. 60 and 70, the change is 10. E is, he got an 80 on the first test and a 60, is it 60 on the next one, so it's going to be a 20-point change. And then D, he got an 80 and then an 80, no change, so the winner is A. So that's how you work that. All right, it seems like they like these number line problems a lot. I think this is the 3rd one we've done so far in this book. On a number line, T, U, V, W, X, and Y, and Z are coordinates of the indicated points. Which of the following is closest in value to the absolute value of U plus V? First thing you have to do is figure out what U and V are. You can tell, you can divide it into sections. I like to count the actual sections instead of the points. So there's 1 section, 2 sections, 3 sections, 4 sections, so it's divided into fourths. So we're going to get, let's see, all we need is U and V. So U is going to be negative 3/4, and V is going to be negative 1/2. So this is U, and this is V. So let's figure out U plus V. So U would be negative 3/4 plus negative 1/2. And we want the absolute value, so we know our answer is going to be positive because the absolute value of negative numbers becomes positive because it's distance. So we have negative 2/4 and negative 3/4 is negative 5/4. We take the absolute value of that and we're going to get 5/4. Now, they want to know which of the following is closest in value to 5/4. So we're going to go up here. This would be 4/4. And Y would be 5/4, so the answer is Y. All right, those aren't so bad, I don't think. All right, now if x is 1/2, what's the value of that? This is a little algebra problem. There's not much you can do to get past this. Well, actually, it's an arithmetic problem in reality because we're just going to substitute 1/2 in where the x is. So it's going to be 1/2 minus 1. So this, when you divide by a fraction, it's the same as multiplying by the reciprocal, so it's going to be 2. We'll do this in 2 steps. 1 over 1/2 minus 1 is going to be negative 1/2. And we're going to flip that guy, so it's going to be minus 2. So the answer here is 0. So it's just a plug and do some fractional work. All right, next ones. Moving right along here. Okay, we have a figure where RS is the same as ST. RS is the same as ST. And since this is a right angle, we also know that side ST is going to be the same as RO, and we can determine that this is going to be a square. So this is a right angle too, and so these have to be right angles. So this one here is a right angle, so it's a square. So the coordinates of K, we want the coordinates of S, it's K3. They want to know what K is, K3. Well, if it's a square, all the sides are going to be 3 units. So if we start at 0, 0, this is going to be negative 3. This is going to be negative 3, 0. So K has to be negative 3. So the answer is A. All right. That one wasn't too bad. Okay, the table gives the values of the quadratic function f for the selected values of x. Which of the following defines f? So basically you're just going to plug in numbers. You're going to put in the x values and see if you get out the y values. We're going to square a number and add 1. Well, let's just try it. If we square any of these, if we square 0 and add 1, we get 1. If we square 1 and add 1, we get 2. If we square 2, that's what we're doing here, we're squaring 2, we get 4 plus 1. 3 squared is 9 plus 1 is 10. I mean, I got lucky picking A for the first one, but all you're really doing is you're plugging the x values in, you're putting the x values in for x, adding 1, and seeing if you get the y value. You have to do multiple points. Just because it works for one doesn't mean it's going to work for all of them. That one worked for all of them. It was really easy to check. So make sure it works for several of them anyway if it's not so easy to check. All right, I thought this one was a little challenging for being a number 10. How old was a person exactly 1 year ago if exactly X years ago the person was Y years old? So what I did here was I just picked a number. I just said, okay, let's see. Now he is, this has nothing to do with any of the letters. Now he's 10. 1 year ago, so 1 year ago, how old was he? He was 9. How old was a person 1 year ago, X years ago? So let's just pick a random number for X. So let's say 5 years ago. So 5 years ago, how old was he? Well, if he's 10 now, 5 years ago, of course I picked one that just worked out to be 2 5s. 5 years ago, this X stands for years ago. And we're going to subtract this from this. We're going to get 5. So 5 years ago, he was 5. So the question is, now I forgot what my question is. Let's see, how many, 1 year ago, X years ago, the person was Y years old. So that he would be 5 years ago. So 1 year ago, let's see, this all makes sense when I did it a minute ago. 5 years ago, all right, now he's 10. 1 year ago, he was 9. 5 years ago, he would have been 5. If 1 year ago, let's just see if we get 5. That's what we're trying to get to, is 5 when we put them in. We're trying to get 9 right now when we put these in. So we have these two numbers. Sorry, I had a mental block there for a minute. So now he's 10. 1 year ago, he'd be 9. So I made up this 5 years ago as a number. So let's do something different since that's kind of confusing. Let's say 4 years ago, how old would he have been? Well, if he's 10 now, 4 years ago, he would have been 6. So we're going to put in these two values in these and see which one gives us the 9, which is 1 year ago. So if we take 6 minus 1, we're going to get 5. That doesn't give us 9. And we're just going to go down the line here until we get the right one. The unfortunate thing, it's the last one. So let's just go down to the last one. So we're going to get 6 plus 4 minus 1 gives us our 9 that we're looking for. So I just picked random values and found out which one would work. All right, hopefully that helped you. It probably confused you more. All right, the sequence above may be changed in either of two ways. Either two adjacent letters may be interchanged or the entire sequence may be reversed. What is the least number of changes needed to put the letters into alphabetic order from left to right? Well, I'm looking at this and I see the X is the whole way to the right. And alphabetically it should go X, Y, Z. So Z is in the wrong spot. I think it makes sense just to reverse everybody at once first. So here we go, X, Y, W, Z. Now the W, we need to get him the whole way over there. So in the next step, I'm going to switch him with the Y. And then in our final step, I'm going to switch him with the X. And it took us 3 steps to do that. So the answer is 3. That one wasn't so bad. All right, how many cubical blocks within the edges of length 4 centimeters, with edges of length 4 centimeters, are needed to fill a rectangular box that has dimensions 20 centimeters by 24 centimeters? So let's just draw ourselves a little box here. You can't really see my box, can you? Because it is in white. So let's just draw our box. I don't have much control here with this thing. Okay, our box is 20 by 24. All right, we have some 4 centimeter blocks that we're going to fill it with. So if they're 4, that means we're going to have 6 going this way, 6 going across this way, and we're going to divide 20 by 4, and we're going to have 5 that can fit in this way. So we can fit in 6 boxes across this way, 3, 4, 5, 6. They look more like circular things because they're 4 by 4. So 4 times 6 is going to give us 24. And then we can get 5 down this way. 1, 2, 3, 4. Oh, this is really bad. I'm sorry. 5 that way. So 30 can fit in that way. Now we also have a height. The height is 32 centimeters. So you have to picture this 3-dimensional. So on top of each other. So you're just going to take 32. You're going to divide it by 4. You're going to get 8. So we're going to take the numbers that fill the bottom of the box, the number of blocks that fill the bottom of the box, and we need 8 layers. So we're going to take 30 times 8, which is 240. Okay, I did that kind of quickly, and I can't draw, which doesn't help me be able to explain it very well. All right, next one. Okay, hopefully I didn't skip any there. 13. All right, this is kind of like the one we did in class where we talked about picking fractional numbers, negative numbers. This one's not so bad because it's in between 0 and 1. We're dealing with a square root here, so we need a fraction. Typically we'd pick a half, but since we're dealing with the square root, I'm going to pick 1/4 because it's easier to do a square root. They have the smallest ones going down here. If you take the square root of 1/4, you're going to get 1/2. If we square 1/4, like what's happening right here, we're going to get 1/16. So what's going to be the smallest one? Well, when you square it, it's going to be the smallest. So we know pretty quickly that this is going to be our answer. Because we're going to square it, it's going to be smaller than this, and that's the only one where the n squared is first. It's definitely going to be the smallest. I mean, you can do that or you can just put them in every one, but if you can see that when you square a fraction, it's always going to be smaller than when you take the square root of it. Okay, that one wasn't too bad because you can pick numbers. When you can pick numbers that easily, the problems aren't so bad. All right, let's slide down here and see this one. In the figure above, what's the median of the slopes? one way you can do it is you can find the slope of all of them. So if you don't know how to find the slope, this isn't how I did the problem, but I'm just going to show you in case you don't understand how I did it. So the slope of A is rise over run. So it rose 3, ran 1. So you have 3 over 1. B, I'm going to go fairly quickly. B is rise 3, run 3. So B is going to be 1. C is going to be rise 3, run 4. D is going to be rise 3, run 5. And E is going to be 1/2. If you put them in order, it's going to be the one right in the middle is going to be 3/4. So that's your answer. And I just eyeballed it. It's right in the middle. So I just picked it right here. It's the middle one. If you put these in order numerically, this guy does end up being in the middle of it. So it's 3/4. Remember, median is the one in the middle. And there's 5, and they're all different. So there's definitely going to be one that's the middle one. All right, here's one of my favorite problems. Actually, it's not, because it messes with your mind so much, and it's probably going to be hard for me to explain. When it's noon Eastern Standard Time in New York City, it's 9 a.m. Pacific Standard Time. You guys know that. Like here at my house, it's about 12, so it's going to be 3 hours earlier in California, so it's going to be 9. It's always like that. Plane took off from New York at noon, arrived at San Francisco at 4 on the same day. So let's just, well, I'm just going to try to work it like I did it. So here's New York. Here's San Francisco. So New York time, I'm going to put, he left it at noon, so it's 12. And he got to San Francisco. I'm going to put that in, let's just keep with, let's keep with Eastern time. So San Francisco, he got there at 4. So I'm going to put the San Francisco time in parentheses as if it's not really real. And the time that the time in New York time is going to be 3 hours later. So it's going to be 3 p.m. Whoops, I mean 7 p.m. 3 hours later. Hold on, they just erased themselves. Okay, 7 p.m. New York time is going to stay out of parentheses. So we're trying to figure out, okay, left at noon, he got there at 4, but really if he's thinking what time is it at home, it's going to be 7. So how long was that flight? The flight was 7 hours. I didn't even read the whole problem to you yet. If a second plane left San Francisco at noon, Pacific Standard Time, that's what that PST stand for, and it took the same amount of time, what was the plane's arrival in New York City? So here we go. This time in parentheses, I'm going to keep my San Francisco time. He left at noon. I don't know if there's a better way to do this or not, but this is what I do. Okay. He's going to go 7 hours. So his time is going to be 7 p.m. that he gets there. Now remember, that's in parentheses because that's our Pacific Standard Time. But in New York, it's going to be 3 hours later. So it's going to be 10 p.m. So the answer is 10 p.m. Eastern Standard Time. A little tricky. Just try to keep your time straight. I use the parentheses. You have to come up with some system. All right, that was harder, but this one's easier. In a rectangle, PQRS above, arcs QS and RT are quarter circles with centers at P and S respectively. The radius of each quarter circle is 1. So the radius is going to be this distance right here. From here to here, from the center to a point on the outside of the circle is going to be 1. So this is going to be 1. 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 And it's a rectangle, so the opposite sides are the same. So the rectangle, this side's going to be 2. So we want to find the area of the shaded region. So we're going to take the rectangle and we're going to subtract from it. We're going to take the area of the rectangle and we're going to subtract it from it the area of a half of a circle. Whoops, let me just put the A. Area of the half circle. And that would give you the shaded region, right? Because 2 quarters are going to be a half. So the area of rectangle is 1/2 length times width, so it's 1/2. And it's not 1/2 length times width, it's just length times width. So it's going to be 2 times 1 is the rectangle. Your half of a circle is 1/2 pi r squared, the radius is 1 squared. So your answer is going to be 2 minus pi halves. I mean, you could probably have looked down and just saw that answer. That this is the area of the rectangle right here. The circle is pi r squared, and it's going to be half, so you're dividing it by 2. So this was B. That's a pretty fast problem once you get it. Okay, what is waiting for us on the last slide here? Okay, we only have 2. That's not too bad. Actually, I think I missed a board. Hold on. I missed one. Okay. All right, the graph is shown above. What is the following could be the graph of f of x plus 2? All right, if you have a function, I'm going to do a little function lesson here. We're going to put it y equals. If I have y equals x squared, what that's going to be is a parabola whose center is 0, 0. Some of you know this, some this is new. Now, if I want to move that parabola up and down, what I do is I'm going to take onto the x plus 2, I'm going to add a 1 or a 2 or whatever. And that moves our parabola up and down the number that are added onto it. So if I added a 1, I would move the whole thing up 1, if that's 1. If I subtracted it, if I did something like this, y equals, oh, that's a terrible color, x squared minus 3, it means the whole thing is going to move down 3. Like that. Okay? If it's outside, it moves up and down. All right, I have to get rid of that color. If instead it changes to this, y equals x minus 1 quantity squared inside the parentheses, instead of it moving up and down, it's going to move left and right. So if we have our parabola, I hope this doesn't bore you to death, just skip this if you know what you're doing. And now I have, this is our standard y equals x squared. If I have a minus 1 inside, it means it's going to move to the right. It's always the opposite, this 1. So I'm going to take, let me find a color, it's not so mean. I'm going to move this whole thing to the right 1. So now our parabola is going to move to the right. If I had something like this, I'm going to run out of room, y equals x plus 2, it means it's going to move to the left 2. 1, 2. So it's going to move over here 2. So if it's in the parentheses, it moves left and right. It's outside the parentheses, it moves up and down. So back to our problem. This problem, it's just saying that the function is moving. It's inside parentheses, so it's going to move. It's the opposite of that. It's going to move to the left 2. So let's find the picture where the whole function picks up and moves to the left 2. Well, here it gets taller. Here it moves to the right. And if you notice on C, it's moving over 1, 2. So this is your winner. Let's look at the last one. This one, or 2 more. This one moved down and this one moved up. They would move down and up if it were added on. If the problem would have said y equals f of x plus 2, that means it would have moved up 2. But since it's in parentheses, it goes left and right. So store that in your brain somewhere. Could come in handy. All right, a geometry problem. They're always my favorite for some reason. In the figure, AB equals BC. So the sides, it's an isosceles triangle. This one's not, it's drawn a little off scale. It's not too bad. DE equals EF equals AF. Is that what it says or not? DE equals EF equals DF. Okay. Now, right away, when you see that, you know the angle measurements. If it's an equilateral, you can just fill in your 60s here. They're all going to be 60. Equilateral triangles all have 60-degree angles. Because it's isosceles, we know that this angle is congruent to this angle. The base angles are congruent. What else do we know? ABC is, this angle up here is 30. All right, now we're just going to work it down. Well, there's 180 degrees in a triangle. So if we take 150, 180, I was going right to the answer, subtract off the 30 for the one angle that's given, we're going to have 150 degrees to share among A and C. So we're going to share it because they're equal. So A and C are each going to be 75 degrees. And I can't really fit all that in there. 75 and 75. What we're trying to find is DFA, which is this angle right down here. I'll just put 2 little slashes there. Well, now we can work it. Now we can work it through a little bit. We know. Do we know more? Oh, I forgot some things. BDE. BDE. This is 50. The other thing we know about 180 degrees, if the angles are collinear, they all lie on the same line, they're going to add up to 180. So we're going to have 50 plus 60 plus what gives you 180? Well, 50 plus 60 is 110. From 180 is going to be 70. So now we have the 2 angles of the final triangle. So we're going to take 180 minus 75. And we get 105, and then we're going to subtract off the 70. I'm sure you can use your calculator to do this, and you're going to get 35. And that is your answer. Like I said, I didn't use my calculator one time on this test. All right, I actually did all the math like that, but I guess it would be easier on a calculator. All right, that one they just want to test to make sure you know triangles 180 degrees, equilateral triangles have 60-degree angles, and if angles lie on a line, they add up to 180 degrees. All right, now we're on the final board. All right, A, C, and F are 4 non-zero numbers. Then all the following proportions are equivalent except. How do you tell if the proportions are equivalent? You cross multiply. So you get AC equals BF. We're going to keep crossing. AF equals CB. Okay, these 2 are not the same, but we don't know who is the wrong one. Here we go. CB equals AF. Again, AF equals CB. And finally, AF equals BC. So to tell if proportions are the same, you cross multiply, you compare them. You could have put numbers in. You could have said A is 2, F is 3, B is 5, C is 6, and cross multiplied, but that's just a lot of work. So the only one that isn't AF, CB, AF, CB, AF, CB, AF, CB is A. So that's the one that's equivalent, not equivalent. All right, the last one I thought was a little hard. So it's our silly symbols again. So we're going to plug them in here. I'm going to put them all out. I'm just going to do them all. I'm going to put them in the symbol thing. So A box B pretty much is A times B minus B. So here we go, because A is the X and B is the Y. So I'm going to get AB minus B. Now let's do the next one. That one was the easy one. All right, now this is your X and this is your Y. So where you see an X, you're going to put the AB. Where you see the Y, you're going to put the B. So here we go. So this one's going to be A plus B times B minus B. All right, now part 3. And I actually didn't do this quickly. So this time, this is the X and this is the Y. Wherever you see X, you put A. Wherever you see Y, you put A plus B. So we're going up here. So X is the same as A. Y is the A plus B. Then we do minus, and the B is Y, which is A plus B. So this one's like a mental mess-up problem. Okay, so if A and B are positive integers, which of the following can be equal to 0? Well, pick numbers and see which ones you can make equal to 0. Now the AB is not going to change. It's going to be the same in all the problems. So if I let A equals 1, it can't be 0, and B equals 2, and I put them in the first one, 1 times 2 is 2, minus 2 does give me 0. So I found a case that works for that one. Now that has to give me 0 for the other 2, or else it doesn't work at all, because these are the only ones that work for this. So 1 is definitely a go. Let's put 1 and 2 in for this one. So 1 plus 2 would be 3, times 2 would be 6, minus 2 does not give us 0. So 2 does not work. Let's go down to 3. A is 1. 1 plus 2 is 3. And 1 plus 2 is 3 again. And we get 0. So that one does work. And that would be 1 and 3. Okay, that's it for Test 6, Section 2.